For this problem, I'll find the auxiliary equation. It'll be in the form a times m cubed plus b times m squared plus c times m plus d is equal to 0. The differential equation will be in the form a times y triple prime plus b times y double prime plus c times y prime plus d times y is equal to 0. The coefficient of y triple prime is 1, so a is going to be 1. The coefficient of y double prime is negative 4, so b is going to be negative 4. The coefficient of y prime is negative 5, so c is going to be negative 5. And there is no y term, so d is going to be 0. I can now write the auxiliary equation. It'll be m cubed minus 4m squared minus 5m is equal to 0. We can factor an m out. It'll be m times m squared minus 4m minus 5 is equal to 0. The first root, m1, will be 0. We'll be left with m squared minus 4m minus 5 is equal to 0. We can use the quadratic formula to solve. It'll be negative b plus or minus b squared minus 4ac over 2a. It should be positive 4 plus or minus the square root of 16 minus 4 times 1 times negative 5 over 2 times 1. This will be 4 plus or minus square root of 16 plus 20 over 2, which is 4 plus or minus the square root of 36 over 2, which will be 4 plus or minus 6 over 2. So m2 will be 4 plus 6 over 2. m3 will be 4 minus 6 over 2. m2 will be equal to 5, and m3 will be equal to negative 1. And again, m1 was 0. All three of these roots are different, so y is going to be in the form of c1 times e to the m1x plus c2 times e to the m2x plus c3 times e to the m3x. I'll substitute these values in. Y will be equal to c1 times e to the 0x, which will just be 1, plus c2 e to the 5x, plus c3 e to the negative x. So y will be equal to c1 plus c2 e to the 5x, plus c3 e to the negative x. And that is our final answer. If this video helped you, consider subscribing.